Hi guys, this is Mr. Katz. This is your homework for tonight. The idea is to kind of watch the video and pause the video after I ask a question. See if you can do it without me doing it, and then, you know, go and play the video and see if you got it right. We're going to do three things on this video. We're going to talk about exponential functions, how to identify them from a table, how to graph them, and how to go from real life into an exponential equation. And we learned a little bit about this today, so you should have a good amount of background to do these things. First of all, here are two tables, and basically what I want you to try to do is write, and these are exponential functions. One, I want to know, do you know why how we know they are exponential functions? And two, could you write an equation from them? So go ahead and answer those two questions, pause the video, and then when you're done, go ahead and play the video again. Okay, so hopefully you got a chance to do that. And these are exponential. This one is an exponential function because you could see that every time you're multiplying the y's times 2, as x keeps going constant, it's times 2 times 2. So this is exponential function. So to write an exponential equation, this normal form is you have the a and then you have a b to the x. Those are just variables that stand for numbers. There's nothing, don't worry if you don't know that one of these is a, one of these is b. The first number is the initial value, or the y-intercept. And you can see right here that when x is 0, y is 12. So I know that the first number is going to be 12. And then times, this is what we call the growth factor. So what's happening every time? Well, you're multiplying by 2. So this number is a 2 to the x power. And this is the exponential. And just to check it, if you go ahead and plug in some of these x's and solve it, you're going to end up getting the y. So if you plug in a 1, 2 to the first power, 1 up here, is 2, times 12 is 24. So this actually equation you could prove works for these. And this one is also an exponential function because you're not multiplying, but you're kind of dividing by 3. And another way to divide by 3 is you could talk about that you're actually really multiplying by 1/3. So we don't, in our growth factor, we don't talk about dividing. We actually always have to refer to as multiplying by numbers. So instead of dividing by 3, it's going to be 1/3 to the x power. Well, what was the y-intercept? What is y when x is 0? Well, you can see right here it's 9. So that's the initial value. So y equals 9 times 1/3 to the x power. It's okay if you didn't use parentheses. Sometimes you'll see it like this. Sometimes you'll see just the parentheses around the 1/3. It all means the same thing. So then the next part of this process is how do we graph these? Well, there's two ways. There's actually three ways to graph these. The first way is you can actually, well, go ahead and try this. Pause the video and see if you can graph these. And hopefully you got a chance to do that. First of all, you could use your calculator. You could actually graph these in your calculator and look at the table and just graph some of the points and then connect them to form what the exponentials usually look like. It's flat on one place and then kind of goes up, and it goes up rapidly towards the end. But if you don't want to graph these, we can also just do a couple things. Like we know in that last slide, this is the y-intercept. So we know that the graph crosses through +4. Okay? We also know since the growth factor is greater than 1, whatever you're dealing with is increasing. So it's going to go up. And it pretty much doubles. So it's going to start doubling, and then at the very end, it goes up really, really quickly. Now, as you move towards this way, we talked about in class that it actually looks like it gets really flat with the x-intercept. This is the x-intercept, obviously. But it doesn't really actually, it goes forever towards the x-intercept. It's not really flat. It's actually moving towards the x-intercept this way. But this way, it's actually going to go, as it moves along, it gets steeper and steeper and steeper. And that's how exponentials work. Well, if you weren't sure where exactly to put your graph, you could also make a little bit of a table. So we already know that the y-intercept is 4. So when x is 0, y is 4. So I can go in and actually do, when x is 1, put a 1 in there. And then do 4 times 2.5. So we're going to talk about our table. So I'm going to go ahead and pause this for a second and then bring up. I brought up the calculator. And we just want to go ahead and plug a 1 in here. So it's going to be 4 times 2.5. Four times, then 2.5, and then to get to the first power. Well, actually, are we doing 1? Oh, well, that's actually pretty easy. 2.5 to the first power is 2.5. So 2.5 times 4 is, oh, sorry about that. There is no exponent. 4.5, 4 times 2.5 is 10. So we know that when x is 1, y is 10. So that kind of helps you understand where the other points are. And if you want to do a 2, we can do that as well. 2.5 to the second power. So 2.5 to the second power equals 6 1/4, and then times the 4. So we can see when x is 2, y is actually 25. So we go to the 2, we'd go up to the 25, we'd graph that point, and then you'd connect all the points, you'd see that graph. But mainly, we just want you to understand like the rough sketch of it, how it kind of looks. What's the y-intercept? So here you have, there is no, for all these problems, we kept talking about the number in front being the y-intercept, and there's no y-intercept here. So if you're ever not sure, I'm going to show you a trick in a second, but if you're ever not sure, the y-intercept is when x is 0. So if you plug a 0 in here, 1/3 of the 0 power is 1. Well, that gets us to a little bit of a, something that you always want to know about exponentials. If you don't see a number in front, it doesn't mean it doesn't have a y-intercept. It doesn't mean it's 0. It actually means it's 1, because you don't see it. 1 times 5 to the x power is 1. So this one, if I asked you what was the y-intercept, you would also say the y-intercept, there's nothing in front, so it's actually 1. So we know that this graph actually crosses the y-axis at 1. Well, this is the growth factor is 1/3, which means it's actually going down. It's losing 1/3 of the value every time. So this is going to go down really, really steep, go through that y-intercept, and then it's going to it looks like it evens out, but this ever goes towards the x-axis without actually getting to it. And we actually say that it's asymptote to this x-axis. And that would be a rough sketch. And if you really wanted to know what it really looks like, let's use some x's that can be divided by 3 pretty evenly, because to the 3rd power. So we're going to go ahead. When x is 1, 1/3 of the first power is 1/3. When x is 2, let's see what that equals. Put 1/3 in parentheses. To the 2nd power, you get 0.111. So really goes all the way down. Whereas 1/3 is 0.333. So here it kind of helps you graph and figure out where your points are in this line. Next part of it. Basically what I want you to do is I want you to go ahead and read these questions, and then I want you to not only write an equation, but answer these 2 questions. And then after you're done, pause the video, and then after you're done, watch what we've done. All right. So here it says 4 students currently are aware of a rumor, and that rumor is Mr. Katz is very cool, obviously, a very true rumor. Since each person that knows tells one new person each day, so each person is going to tell one person each day, that's essentially what's happening is the rumor is doubling. The amount of people that know every day is going to double, because when 4 people each tell a person, now 8 people know. And then when those 8 people tell another person, now 16 people know. So the first thing is to understand that if you're doubling, that's an exponential function. So we're going to write an equation for it. Y equals, so in here, there's an initial value, it's 4. And then, what's happening every time? What's the growth factor? Well, the growth factor is 2. And we know that to know how many times we're doubling it, that's the x. That's why it's an exponential. That's an x right there. Sorry about that. So now we have our equation. So it says after 4 days, how many people know? Well, this is easy because we're just telling you what the x is. So y equals 4, and then 2 to the 4th power. So 2 to the 4th power, so I could actually do this in my head. 2 times 2 times 2 times 2 is 16. And then 16 times 4 is 64 people. So 64 people know. Now to answer the next question, how many days will it take? Well, now I'm telling you what y is supposed to equal. And you guys right now in Algebra 1 do not know how to take an equation and solve for x when x is an exponent, how you can get x and move it down so that it's not just an exponent, it's an actual variable down here. So instead, what we talked about in class is that if you go and graph your quadratic. So let me go ahead and graph it. So we're going to go on to our graph, and we're going to y equals, and I'm going to go ahead and plot the equation, which was 4 and then 2 to the x power. Hit graph, and then we don't really need to see the graph. What we're going to do is we're going to go to our table. You can see the exponential. So on our table, we're looking for when will 100 people know this rumor. Second table, or second graph. So I can see right here. So at the 4th day, there's 64 people know. On the 5th day, there's 128. So you could answer this question by saying pretty much by the 5th day, it's obviously over 100 people, but after the 4th day, 100 people, by the 5th day, 100 people are going to know. On that 5th day is when the 100th person is going to be told. So now we get to the next question. Miss Kellerman bought a new car, and it's a Scion. She wanted to buy a really, really cool car, okay? And for $20,000. Each year, the car is only worth 4/5 of its original value. So first of all, go ahead and answer these questions. and then pause the video, and then we'll go through and talk about them. So first of all, the equation is with the initial value. She bought it for 20,000, and if it's 4/5, that means we're going to multiply 4/5 times that initial value, and we're going to do it by every year. So x is the number of years. We don't know. It could be a number of years. So when is the car worth in 3 years? So that's going to be, we take our equation, and we take the 4/5, and we're going to go ahead, and now we know that x is 3. So 4/5 to the third power. 4/5. Going to hit enter just to get that decimal. So to the third power. Or you could have also done this. 4 divided by 5, 4/5 to the third power. Either way, you get the same answer. And then we're going to multiply that by the original cost of the car, because that's just following the equation. And you get 10,240. So in 3 years, the car is now worth $10,240. So it says, when will the car be worth under 5,000? So that's when, again, we're giving you the y value. So there's nothing, you can't really plug, you don't know right now how to plug the 5,000 in and then solve for x. So instead, when we have a question like that, it's easy to plug in the x, but when we want to find out something for y, the best thing that we can do is go to our graph, and we're going to type in the new equation. Oops. So this equation was 20,000. Oops, I think I did too many. Yep. Now it's 20,000 times 4/5 to the x power. And I'm going to hit graph, but we could just go, pretty much we can go straight to our table. And we can see the cost of the car after this is the number of years, this is the cost of the car. So when will it hit $5,000? So in the 6th year, it's actually worth $5,242. And as I scroll down, you can see that the 7th year should dip under that. So it's not really worth $5,000 until after the 6th year. So that's what I would write, after the 6th year, because the 6th year, it's actually worth more than $5,000. So you could either say in the 7th year or after the 6th year. And that's how you do those problems.